let's do video number 2. This is student-facing tasks for lesson 4, video number 2. Unit 8.5.4. Okay, in the last video that we finished, in video 1, you saw this graph. The last question that you just finished had time on the y-axis. And the distance the runner had gone on the x-axis. And we saw that the time depended on how far they had run. The more distance away, the longer the time took. So we said time is a function of distance. Time is a function of distance. That meant the time it took depended on the distance away from the starting point. The farther the distance, the more time that it took. Now, we're going to look at another graph. And this graph shows you that time does not always have to be a function of distance. Sometimes the time it takes doesn't depend on the distance away from the starting point. So imagine a circular running track where you start at t equals 0 and you run to the other side of the track where you turn around and come back to your starting point around a circular running track. In this case, the time that it takes does not depend on your distance from the starting line because your distance increases and then decreases. So let me draw this track. Very similar to the track I had at my high school. The starting line was here. I'll call that like distance equals 0, whatever. And then runners go around the track. And right about here, their distance is the farthest from the starting point. But then they start to come back. As they come back, their distance from the starting point is decreasing because they're getting closer to the starting point. In that situation, if you measure the distance from the starting point, then that distance is decreasing after the halfway point. Let me give you another example. I used to run a lot of 5K races and 10K and half-course marathons and even marathons. Many race courses have you run, and then at some midpoint, they call it the turnaround. Runners love getting to the turnaround because that means you're halfway done. And then you would come back to the starting line. So at t equals 0, that means at the starting time, my distance is 0. And then at the midpoint, my distance would be like 13.1 miles if it's a full course marathon. 13.1 miles. Then I do a U-turn. And then my distance from the starting point after the U-turn starts to decrease because I'm coming back to the starting line. Finally, I have ran a total of 26.2 miles if it's a full course marathon. But my distance from the starting line goes back to 0. And my best time ever was never too good. Maybe 4 hours and... Gosh, I don't remember now. My worst time was 5.5 hours. My best time was only like 4 hours. Anyway, never mind my old running days. Forget that. I'm not even a good runner. I just tried my hardest. Okay, so what you're going to learn on this problem is time does not always have to be a function of distance. The time it takes doesn't always depend on the distance from the starting point. Okay, let's answer the questions. Priya is running once around the track. The graph shows her time given how far she is from her starting point. Not total distance, but from her starting point. A, what was her farthest distance from her starting point? Well, we can read this right off the graph because the distance increases and increases and increases until we get to some turnaround point. and then go down to the x-axis where it says distance from starting line in meters, and you have to read what that distance is. However, it is not written on the scale. You have to figure that out. You can see the scale increases by 25 meters for every tick mark. So 175, the next tick mark would be 200. The farthest distance from the starting line that she ran would be 200 meters. It tells you do not include units of meters in your answer. So don't type in 200 meters. Just type in the number 200 and go to the next problem. Now, estimate how long it took her to run around the track. It says estimate because when she returns to the starting point, that ending point is not on a grid line. So you have to estimate what it is. It's more than 72 seconds, but less than the next grid line. The next grid line would be 84 seconds. It's less than 84, but more than 72 and closer to 72. So what's your estimate? I'm going to estimate 75. And I like it if you give me your answer in a sentence. I estimate it took her 75 seconds to run around the track because on the graph, that is where her distance is 0. Actually, there's 2 spots where her distance is 0. But anyway, that is where her distance is 0 at the greater time. At the greater time? At the greatest time?
I think you know what I mean. I hope so.
Okay, type in your answer and try to get your spelling right, unlike me. Oh, man. Forget spelling. I'm going to submit it with bad spelling. I'm not a spelling teacher. Estimate when she was 100 meters from her starting point. Okay, so there's distance from the starting point on the x-axis, and I can easily find on the grid line where it says 100 meters. So now I need to see where her graph crosses. And it says estimate. That's because her graph crosses the 100-meter grid line, but when I look at the time, it does not hit a grid line. I have to estimate what that is. It's between 12 seconds and 24 seconds. And then the other point where she is 100 meters from the starting point, that is between 48 seconds and 60 seconds. There are 2 points that are 100 meters from the starting point. I want you to explain that in your answer. There are 2 points. Wait, there are 2 points when Priya was 100 meters from the starting point, comma, at, and then what's my estimate? Maybe 18 seconds? At 18 seconds. And then my other estimate, 48, that must be about 54 seconds? I don't know. I'm not sure. It's an estimate. There are 2 points when Priya was 100 meters from the starting point at 18 seconds and 54 seconds. Estimate how far she was from the starting line after 60 seconds. Okay, now here they tell us to estimate, but they're expecting you to give an exact answer, and you know that because of this green bar, it's automatically scoring the problem. When you have a text box, then I go through and read what you wrote and I score it. But here, the computer is going to grade you. You have to give the exact answer. Can you give an exact estimate? Well, on this one, you can. Because when you find 60 seconds on the y-axis and you go over to the graph, you see that the graph of Priya's graph is exactly on the grid lines, where these two grid lines meet. So you can easily go down and exactly read the x-axis. The distance is 75 meters at 60 seconds. So after 60 seconds of running, her distance was 75 meters. Make sure you see that yourself on the graph. Is Priya's time a function of her distance from the starting point? That means, does the amount of time it takes her to run depend on how far she is from the starting point? Well, no, because at first she's close to the starting point, and then the distance from the starting point is increasing as time is increasing. But after she goes around here, then the distance from the starting point is decreasing as time is increasing. So it doesn't depend on the time that she's been running. First it's increasing, then it's decreasing. So no. And now I'm going to teach you something new called the vertical line test, and I want you to put this in your notes. How do you know if the graph shows a function or not? You can do the vertical line test. Please write this in your notes, the vertical line test. And what that means is, if we hold a straight line to a graph, and if we can draw a line, and that graph crosses our line in two places, what that means is, if we have one input, there are two outputs. Let me explain again. I'll draw the line right here at 125 meters. And remember, in the beginning of this lesson, you learned that the x-axis is the independent variable. The x-axis is the independent variable. Don't forget that. You have to remember that. Independent variable means the input. And you learned at the beginning of this unit that the y-axis is the dependent variable. I'll just put a D for dependent variable. That is the output. Actually, you can change which axis you want it to be on, and you're going to do that a lot later. But on this graph, the way it's set up now, the input is the distance from the starting meter, and the output is the time. So when I draw a vertical line on this graph, I can see that the input of 100 meters has two outputs. At 100 meters, she's 18 seconds along and also 54 seconds along. It means one input has two answers. But we can't do that. You remember the function rule, right? Each input can only have one output. This graph breaks the function rule. So you know that the dependent variable is not a function of the independent variable because there are two answers for each input. That sounds really confusing, so what I just need you to remember right now is the vertical line test. If you draw a line and the graph crosses twice, it is not a function. Let me draw another graph to explain the vertical line test. Let's say we had a graph that went like this. The function, not a function, the thing that you're graphing goes like this. Like someone's running in a zigzag pattern, or the amount of money in your bank account is going crazy, or something like that. Like if this is the month, I'll just put some units here. Months on the y-axis, and let's say that this axis is temperature, Okay, you're reading the temperature each month, average temperature. Then as the month increases, the temperature is increasing, and then the temperature is decreasing, and then the temperature is increasing. So that means that the month does not depend on what temperature it is. But if you were to turn the graph this way, you could say, the temperature depends on what month it is. So try the vertical line test in the lesson 4 practice problems. If you draw a line and it crosses the line several times, it is not a function. Please remember what the vertical line test is. And also remember, vertical means up and down. I always got that confused when I was young. Vertical? Horizontal? Okay, vertical goes up and down. So draw an up and down line. Good luck, guys. Submit your last answer and, there's more. I didn't know there's one more. Explain how you know that the distance from the starting point is not a function of time. Okay, let me explain it real quick. It is, I don't like to say it. I like to give the exact words. The distance from the starting point is not a function of time. That means does not depend on. Does not depend on the... I think I have it backwards. The time does not depend. Oops. Sorry. The time. The time does not depend on the distance from the starting point. Because at 100 meters, there we go, because at 100 meters from the starting point, there are 2 times. In other words, each input of time has 2 outputs, and that breaks the function rule. The distance from the starting point does not depend on how long she's been running, because first it's increasing distance, then it's decreasing distance. So it doesn't depend on it. Okay, phew. Pause the video and make sure that you write down your answer in a way that I can understand that you understand. See you later.